Hey, in this video, I will show some of the details for my small Logic Trash Driver project. You can see vehicles driving around and spawning workers, which then pick up trash. The green guys help them by carrying it to nearby workers, and the red guys spawn new trash. Okay, first let's have a look at the state machine for the vehicle. In the driving state, I just use the getContext to cast to the actor, and there I set a bool stopped. The actual driving logic is implemented in the actor blueprint. I use a timer to check every couple of seconds how many trash actors are nearby, and update an array. Inside of the transition, I will just check if the nearby amount of trash is over a threshold, and then I will transition. The logic inside the cleaning state works like this. I first have some simple logic to see how many workers I need to spawn depending on the amount of trash. I then spawn the worker actor and set a reference to the vehicle state machine in their state machine. This is actually all the logic of the vehicle. I then only check if the worker and trash task array are empty in the transition. Let's have a look at the worker state machine. The first state is just to make sure that vehicle reference is valid, because I will set it after the worker has spawned and the state machine has already started. The other states are get new task, which is used to find a new task from the vehicle state machine, finish, which is entered when there are no more tasks available, and pick up and deliver, where I pick the trash up and deliver it to the vehicle. Time to dive in. I just use the vehicle reference to check if there are tasks available and get one. After that, I will call either start task or all tasks finished. You can see the list of event dispatchers on the left and add also new ones there. To bind a transition to one, you just have to select it in the list, delegate property name. Before I forget to mention it, the tasks are just references to actors. This has the advantage that I only need to deal with a single variable, and if the actor gets destroyed, the task would get invalid by itself. Okay, let's have a look inside of the pickup and deliver state. It's actually a nested state machine. The advantage of these are that it's more organized and that the transition logic will apply to all of the states inside of it. Here you can see the transition is bound to the delegate task finished. It doesn't matter in which of the substates it is, it will always transition. Inside of walk to trash, I will just walk to the trash task I have taken from the vehicle. I use a timer to check every 1 second how close I am to the trash, and then claim it. Claiming will just set a variable inside of the trash actor to my actor, so that only a single worker will try to pick it up. In this case, I decided to only claim it if I get near to it. This will cause more interesting behavior because 2 workers might try to pick it up, but stop if another has claimed it before themselves. In the same timer, you can see I will check if another worker has already claimed it. So in this case, the communication happens over the actor we want to interact with. For the trash actor, I have a variable for the claiming worker and for the guy holding it, because nice guys can still pick up trash when a worker has claimed it, and workers can pick up trash from nice guys even though it's already picked up. After we have reached the trash item, we will enter the pickup state. In this state, we will just call a function on the trash actor which handles all the pickup logic. The transition for this state is always true, so it will instantly transition to the next state. I could join the logic into one of the other states, but having it like this can make the graph more organized. The last state is used to return the trash to the vehicle. It's again quite simple. I will walk to the vehicle, and after I have reached it, I will call a function on the trash which will handle the rest. That function will check if the trash is inside the vehicle and destroy it after some time, and if it leaves the vehicle, make it available again for workers to pick up. In this state, I use the update function, which will happen every frame. I use it to rotate to the vehicle after I get close to it, so that the trash will land inside of the container when it is thrown. The nice guy will help the workers by picking up trash and carrying it to them. They will just walk around until trash is nearby, and then transition into the pickup and deliver state. The only interesting thing inside of here is that I use a parallel state. You can enable it by clicking on the entry node and allow parallel entry states. Then, you can just use a state to define behavior for starting or ending of the nested state machine. So I don't need to have this code in all the states. Here, we will check if the trash actor is still valid, and if the trash actor was claimed by a worker, so we can walk to them. Also, if the trash actor is still held by this guy, because after the worker has picked up the trash actor, the variable picked up by will change. This is how the state machine looks while simulating. We are now coming to an end. I hope this video was informative for you. If you want to learn more, you can find the free project download in the video description. Also, don't forget to leave a comment to let me know what was good and what was not. And feel free to ask any questions.